Right, this is the second activity sheet from Unit 10, and we're going to work on some systems of equations. One really important thing to be able to do is set up a system of equations based on the information you're given. There's always going to be two variables, two things that can change. So in this situation, we're going to keep track of those two things, and then you'll have an equation for each situation or perspective, looking at those two variables, okay? Notice they have options in this case, one option and two option. Each of those is going to be an equation, keeping track of the same two things. That's how we set up a system of equations. So we've got the cost of repair will be 100 for what? We're repairing a gas-powered mower. Great. And it's going to cost 160, after which the cost operating the repaired mower is $45 per week. Okay. So if I want to do that, notice $45 per week. So we're going to pay $45 over and over again based on how many weeks. Hey, look at this. We'll read that in a moment. The other possibility, we got to pay $400 for this lawnmower to fix it, but it only costs to buy a new mower, but you're only going to pay $15 per week because it doesn't waste as much gasoline, doesn't require as many repairs because it's brand new. So we can use the old one and repair it, or we can buy a new one and pay less for gas per week. The question is, basically, well, we'll get to the question in a moment. Create an equation for each of these. Okay, so our first option, we're paying $160, just straight up. I am not going to put that right here. The reason I'm not going to put that right there is because that's being multiplied by x. And they're saying that x is the number of weeks that happens. Right? Y is the cost, how much we're paying, so $160, but this is not how much we pay per week. We're not multiplying this by the number of weeks. We're just paying this straight up, 160. So I'm gonna go ahead and scoot it over here. So it's just a standalone number, plus 160. I only pay 160 once, but I do pay $45 per week. So that's what I'm gonna write in here. 45, boom, we got it. All right, so that is our option number 1. Think about what the option number 2 would be. Type it in and see if you get it right. Now I'm going to type it in. All right, here's what you end up with, $15 per week plus $400 off the top. And there we are, we got our equations. Okay, Desmond's best option, which will be the option for total cost, Desmond's best option will be that option with the smallest total cost over the rest of the mowing season. Okay, so how many times is he going to mow the lawn is the big question. Because if he pays $400 for a new mower, that's a lot of money. But then he's only paying a little bit per week, right? So assuming he mows a lot of lawns per week, this might be a better deal. But here, we pay a lot more per week, but a lot less upfront. And so the question is, which is a better deal? Well, if there is little time left, then I would repair the old mower. It would cost more per week, but there wouldn't be that many weeks to pay for. Right, so I would go with option 1, because if there's not much time left, if there's little left time mowing, say there's only 2 weeks left, you're going to pay $160 plus this twice. That's going to be a lot less. That's going to be way less than $400. However, if there are 10 weeks left, that's going to be a lot of money actually, right? So if there aren't that many weeks left, which is probably best if the season's just begun, buy the new mower. It will cost more up front, but as time goes by, you will save money each until it is less expensive. There, that'll work. So I hope that makes sense. We have an old mower, repairing it for $160 and cutting for $45 per week, or we're buying the new one, $400 and paying $15 per week for the gas and everything. All right, it would be useful to know which of the two options results in the same total cost, right? When are they equal? That's a useful thing to know. When will this cost the same amount as that? And that's what we find out when we do systems of equations. We find out when the x's and the y's are the same. So when is the cost and the number of weeks the same in this case? Well, if the x and y are the same number in each equation, that means we are paying the same amount and using the mower the same number of weeks. That is when they are the same cost. Okay, so that's what we're going to say. How can he figure this out? Well, there are lots of ways we can do it. Okay, we can graph, and we'll talk. There's graphing. This will always work if you have Desmos, but sometimes I'm going to require work shown. So one way we can do it is to type these in like this: Desmos y equals 45 x plus 160. The other one was y equals 15x plus 400. I just got to zoom out a bit. You can see our two lines there. What's going on here? They cross somewhere up here. They cross right there at 8,520. We'll talk about what that means, but that one is the weeks and one is the amount of money. I bet you can guess which is which. We'll come back to that. So all I did was type them in and find where the lines cross. That's how we did it in the last assignment. There are other ways though. Okay, how would we find them? That's one thing we're going to talk about. Graphing is one. We learned substitution. Another way. We learned elimination is another way. Another way that they'll talk about is using a table. Now, I will tell you, using a table and making a graph are not always the best way to solve it. For math problems in a math book, usually works. But often in real life, I mean, what if they never have a specific week? What if one of them passes the other one and it's like 2.75 weeks or something like that? It's going to be hard to see that on a graph. Okay, so for example, if I paid, well, I don't know, $17 per week for this one instead of 15. Now, where they cross, it's going to be a lot more ugly. Means that about 8.5 weeks, just a little over 8.5 weeks in, it's going to cost $545.71. That's different. Okay, so changing one number can really change where they cross. Okay? Back to the 15, and they cross in 8 weeks, you pay $520 for each of them. Okay, so that's a really important thing to realize. So tables and graphs, if I have a real life situation and this is 17 instead of 15 or some ugly number, then you're probably going to want to use one of the other ones. So that's why I'm going to underline these guys are simple. Whereas these guys right here are for complicated situations. They'll solve anything. That's why, oh gosh, what am I doing? These are more complicated to solve any situation. Okay, and that's why we use them later. That's why we save them for later, usually to learn, because they're more complicated. Also, because if you get a more complicated situation, you need them. Okay, so that's why we learn those. I know the graph might seem so simple, but we need to learn the other ways. What is a solution to the following system? Well, the solution is, we're going to do it by substitution. Well, yeah, we will do it by substitution. What I'm going to do is, I'm going to take this y, I'm going to take this y, and I'm going to change it to that. So I'm going to end up with something that looks like this. 45x plus 160 equals 15x plus 400. Now that makes sense. Y is how much it costs. We're saying, when will this cost the same amount as that? And we're going to find out when they cost the same amount. We just have to solve the problem. I'm going to take away 15 x's from each side, and I'm going to have 30x on this side. That's 160 equals, the 15x is gone, and we have 400. I took away 15 x's from each side. Now I'm going to take away 160 from each side. 30x equals 300, 240. Now I divide by 30 and I get x equals 8. 8 times 30 makes 240, I promise you. And now we have a solution, yay. X equals 8. In 8 weeks, they will cost the same amount. Now I just plug 8 in. This is the mathematical way to do it. It doesn't matter which one I pick. I'm going to say y equals 45 times 8 plus 160. Put that over a tiny bit so it looks better, like so. 45 times 8 is, oh gosh, 4 times 8 is 36, plus 5 times 8 is 40, 360 plus 40 is 400. Yep, 400. No. Yeah, 400. Y equals 400 plus 160. Y equals 560. So after 8 weeks, they, both options, cost $160. And that is what we found out. We found 8 weeks, 560. If I was putting that on the graph, that would be the solution. 8, 60. And hey, what was that on here? 8, oh, 520. I mismultiplied. I did do that wrong. 400 and 320. Yeah, this is the wrong number. 320 plus 40 is 360. I made a mistake. My bad. 32 is 8 times 4. I made a mistake multiplying. All right, moving on. What does the solution to this tell us? Well, here's what we know. At 8 weeks, they cost the same. For more than 8 weeks, the new mower will be a better deal because less per week. For fewer than 8 weeks, the old mower will be better because less money up front. You didn't have to pay as much to buy it or fix it, right? And that's what we know. So we found out where they're equal, and we can use that to figure out what's a better deal if you go more or less than 8 weeks. So finding out where they're equal is very important. It's like you're dividing a line. Okay. The two ad options. Now we're buying ads. Great. $10 a week plus 12.5 cents per click. $6.25 for a week plus 20 cents per click. What does that mean? Okay, so we'll talk about that. Set up an equation to model for the total cost of each option if Desmond runs ads for the week. Then use a graphing calculator to help you determine how many clicks it would take for the two options to result in the same total cost. Okay, so, all right. This one's a little more complicated because now we have two things that are changing. Last time it was like one thing that's changing and then something that's not. So here we're going to have $10 per week plus 12.5 cents. 12.5 cents. That is the first situation. The second one is $6.25 per week plus 20 cents. Click. Then at 20. You can see that cents. All right. That's interesting. Okay. So this is the situation. We want those to equal the same amount, right? Okay, so now I just have to combine them to say the same total cost. This is how much one thing would cost. This is how much the second one would cost. Right? Now, I'm thinking the way that, just in case you're wondering, I'm pretty sure what they're saying is you pay $10 to get the ad, and then they also charge you every time that someone clicks the ad, because that's the way you're paying for people to come look at your website. So if the ads are really nice, people will click them a lot, and you get lots of attention, plus the company that makes them also gets a little extra money. So that's the way it's set up. All right, so I'm going to say the same total cost. So the top one and the bottom one should be the same cost. They should be equal. So I'd write 10W plus 0.125Z should equal 6.25. There's something missing here. Well, we'll get there. Oh well, 6.25 W plus 20C. I'm going to roll with this. They didn't give us enough information is what they didn't do, because there are different number of things. Oh, I see what they're saying. Oh, maybe it's just within 1 week. So they don't want us to keep track of W. We're not keeping track of weeks. We're just keeping track of clicks. They never ask about weeks. They assume that there's only 1 week per week. We're only keeping track of it in terms of 1 week. That's not very well explained on the actual sheet. It's probably explained in AgileMind. But with weeks as well, this would not be solvable. Why? Because there's a rule that says I need as many equations as variables. And these over here are not equations. They're just formulas. We need to have that equals something. Like we know that this is equals a certain number of days or something. So the way it was written before was impossible to solve. But now, it's not impossible to solve. So we're going to assume that that's what they meant. Okay, so now we need to figure out, so this one costs $10 up front plus 12.5 cents per click. This one costs $6.25 up front plus 20 cents per click. All right, so what am I going to do? Well, I'm going to take away $6.25 from each side. $6.25, that's going to leave me with $3.75 on top. All right, what does that mean? Well, we'll get there. It means that this one charges $3 more, $3.75 more up front than that one. But it also charges less per click. So I'm going to take away 0.125 cents from each side. 125 clicks or whatever. 0.125. I'm going to take that away. So that's just going to leave me with $3.75 over here. Now I just have to subtract 0.125. That's 12 from 20. That's like 8. It's 7.5. So it's 0.075 clicks. So what that means is 7.5 cents per click. This one costs 7.5 cents more per click than that one. And that's got to add up to a total of $3.75 so that this one costs the same amount as that one. I'm not being very clear, but that's okay. I divide both sides by 0.075. I'm going to do that with a calculator because I'm just not quite fresh in my brain at the moment. So 375 divided by 0.075, that gives me 50. Wow, nice and pretty. That's the answer. So what that's saying is these ads should cost the same amount if there are 50 clicks per week. That's what's going on. So this one right here, if I'm paying $10, I better get a lot of clicks, right? But if I'm paying only $6, if I get enough clicks, I'll actually cost more. This one will actually cost more because it charges more per click. In fact, if there are 50 clicks, the top one costs the same amount as the bottom one. That's what we figured out. Okay, there's a way to do that with a graph. It's shown right here. Okay, oh, this is newspapers. Wow. For each newspaper, write a system of equations that models it. All right, we're going to go back to here. 2 newspapers. Okay, here's newspaper plans. All right, 1 week ad online. There it is. They've got this one, number of clicks, total cost for first payment plan, total cost for second payment plan. Ugh. Okay. For each newspaper, write a system of equations that models the total cost of its 2 payment plans. All right. Oh, I see. So this is payment plan 1 and payment plan 2. I get it now. Sorry, this is like the one that charges, it'll only cost $6 if you get 5 clicks. This one over here, however, costs $9.25 if you get 5 clicks. So it's a better deal, right? The bottom one on the left. But if we keep going, eventually, this one will be a better deal. You can tell because this goes up to $7.50, $1.50 more. This one only goes up by what, 75 cents? No, $1.25 more. So this goes up by $1.50. This goes up by $1.25. Right? So every time that we get 5 more clicks, this one costs 25 cents more than that one. So eventually, this one will be the more expensive one. It's not now, but eventually it will, because it charges more per click, per 5 clicks, right? All right. Write a system of equations that models the total cost of its 2 payment plans. Okay, so here we go. For each newspaper. Oh, this is payment plan 2, I see. All right, so the first one over here, we're going to say, well, payment plan 1 charges $6. $6 plus, is that per click? If it takes 5 clicks to make $1.50, let's see, 5 clicks to make $1.50, that would be dividing, it would be 30 cents per click. I'm going to put the 6 over here just for the record. The bottom one is they charge $9.25. You know what? I did this wrong, but we'll talk about what's wrong with it in a moment. I have to change this guy right here, plus $9.25. Here's the deal. Technically, it also charges, wait, this one charges what? It charges, instead of 30 cents per click, it charges by 5, 125. That's going to be 25 cents per click. However, here's the deal. We actually have 5 clicks to start out with, so this number's wrong. Because I have to take away 5 clicks. I have to take $1.50 away from that. 4.50. And then you pay 5 clicks. After 5 clicks, now you're up to 6. And this one doesn't start at $9.25. It takes 5 clicks to get to $9.25. It actually starts at $8. All right. This one over here, on the other hand, let's do this one. All right. So now we got our other thing. This one's a model. Notice we have y-intercepts. We also know how far it goes over and how far it goes up. So we're going to do that. We're going to say y equals something x plus 15 and y equals something x plus 5. Now we just have to figure out how fast they're growing. Now this one goes, after 25 clicks, it goes up to 17 and a half, right? 25 clicks goes up to 17 and a half. That's 25 clicks. That's the distance this far. And then it goes up from 5 up to 17 and a half. That's 12.5. All right. Now 12 happens to be half of 25. So that's actually a slope of 1/2, 0.5. In other words, this newspaper, charges 50 cents. Rough. Right? The other one, however, so let me really quickly go back to here and make sure that you understand this. That one. Now we're going to do the other one. It's going to be in red. This one starts at 15, and after 25 clicks, it's only gone up 2.5. Same number of clicks. What is that? That's 1/10. So this slope is going to be 1/10 or 0.1. I did how much the rise over run, right? So I'll say 0.10 cents. So Here's what we got. This red guy here. Only goes up by 10 cents per click. It's the cheapest per click, but it's the most upfront, isn't it? Depending on the situation, you might do the thing. So now we're going to find our solution for these two. Well, this one already has a solution, right? The solution is, it's right there. It's given on a graph, 25, 17.5. If there are 25 clicks for your website or whatever, then these plans will both cost $17.50. What that means. Whereas this one over here, let's graph it really fast. 0.3C 450, 0.3X, well, that's fine, plus 350. So that's right, 0.3X plus 450, and then the other one's 25 and 8. 450. 25 X plus 8. There. Okay, now I've got to zoom back in there. We'll see what these look like. So here's the one that starts at 450. Here's the one that starts at 8. There. And they're getting closer and closer and closer. I'm going to have to zoom out so I can see better. Oh, they cross somewhere up here at 70, 25, 20.5. What does that mean? Well, 70 is the number of clicks, and 25.5 is what the cost is. So we know that. $70, 25.5 means if there are 70 clicks, then these plans will both cost $25.05. 25, I mean 50. And that's what's going on there. I can see which one's a better deal of these two. Well, I can figure it out from here. I could compare them now. This one right here, clearly the one that charges 50 cents per click is a worse deal if I get any more than 25 clicks. On this one, the one that charges 30 cents, not 25, the one that charges 30 cents will cost more as long as I have more than 70 clicks. So based on what I can expect, I can make a good decision business-wise. That's why people do this. Lots of business people use systems of equations this way. All right. Bianca pays $25 per month for her cell phone bill, plus $15 for data. Tanya pays $5 a month and $20 for every gigabyte of data. All right. Who's has a better deal? So we're going to say the cost, Y, equals one person pays $25. Actually, I will make cost be C. We'll change it to Y and X some other time, but this is clear. Cost and month. Month is M. Plus $15. We're not worrying about months. I keep forgetting about that. $25 for the month plus $15 for every gigabyte. We'll say G for gig. All right, the other one costs $5. We had $20 per gig, which is a better deal. For me, because I don't use a lot of data, I would definitely go with the bottom one. If you use a lot of data, the top one's eventually going to be a better deal. Okay, So we're going to type these in. I'm going to change these to x and y. And I'm going to graph them. Y equals 25, 15x. Y equals 25 plus 15x. X. The other one was y equals 5 plus 20x. 5 plus 20x. I've got these two things. Where do they cross? Somewhere up here. Here's where they cross, 485. What you can do is you can export it, export the image, download it, and you can put it in here like so. I can just say 8, what do we say, 8? 485. Okay, so we'll go back here and we're going to say 485 is the solution. You just have to put it in the graph. I'm going to do insert, add media, add photo. Come on, my computer, I guess. There it is. Like so. That's what the graph looked like. I'm not being too careful. Okay, so we're keeping track of, this is gigs, and this is the cost, or C is the cost. So 4 gigs costs $85. That's what we're finding out. So for both plans, 4 gigs costs $85. And that's what we need to know. Okay, last one. Andrew challenged his cousin to a race. Since Andrew is older, Kyle insists on a head start. Andrew agrees, gives him a 20-meter head start. Andrew runs at a constant rate of 8.5 meters per second. Kyle runs at a rate of 6 meters per second. Set up a system of equations. Okay, so Kyle, we're going to start with Andrew. Andrew, his distance equals 8.5 meters per second. Whereas Kyle runs 6 meters per second. But Kyle gets a 20-meter head start. How far they each go from the starting line. Kyle starts 20 meters from the starting line, and he only runs this fast. Whereas Andrew runs that fast, and he starts at the starting line. So this is our situation we've got. This one, what we're going to do is we're just going to say they're equal. We're going to solve this one using substitution by saying this equals that. When are they the same distance from the starting line? That's going to be this equals that. So I'm going to do this one without a graph. You can do it with a graph. You could graph it just like the other one, but I'm going to say, when does 8.5 meters per second times distance or whatever, seconds, sorry, equal 6 meters per second. That's the 20-meter head start. Okay, well, I'm going to take away 6 meters, take 6 s's from each side of this. I'm going to stop thinking about them as seconds and just think about them as variables. And that's going to leave me with 2.5 s's over here equals 20. In other words, Andrew is going to gain 2.5 meters every second because he runs that much faster than his brother. And how long is it going to take before he catches up the 20 feet and that he overtakes Kyle in the race? That's what's going on here. I divide both sides by 2.5. That's going to be 5, 4. It's going to be 8. It's going to take 8 seconds for this guy to catch up and run 20 feet more than his brother. All right. That's the way I want you to solve it. I'm going to say already solved using substitution. Okay. It is very important for you to know how to do substitution. The way we do substitution is to take something from one and substitute it in for the other one. I replaced this bottom D with 8.5. I substituted it in like this. I just went, that's what I did. All right. And that's substitution. That's why substitution is called substitution, because I literally plug something in, I substitute it for something else. Show how both the table and the graph can be used to determine how long it takes for Andrew to run. Oh, sure, we'll put a table in there. So we know it takes 8 seconds, right? All right, so let's see where that is. The nice thing about the graph, we'll use the graph real fast. We're gonna use the graph. The nice thing about the graph, it'll also give us how far they went. I could figure that out. I know in 8 seconds, I can figure out how, I just plug it in here and figure out how far they'll run. But let's use the graph real fast. X equals 8.5y, or y equals 8.5x. And y equals 6x plus 20. There. That's our two equations. They start out, he's 20 ahead, and he's catching up as they go. A red line is the older brother who's faster. And they cross right here at 8:68. In other words, oh, I can, by the way, I'm going to export that. I'm going to see if that works. Oh, I don't know if that did work. Control, I'm going to do screen capture. How do I do screen capture on here? Print screen. Control F10. I'd like to leave that there. Export image, whatever. Download ping. We'll see what ends up happening. I'm going to upload it, so I'm going to say insert photo from the computer. Let's see if that worked. Okay, I don't think so. I'll figure out how to do that another time. I'll just use this one. Okay. Oh, come on. The lines cross at 8, I believe. Isn't that right? Oops. 8:68. That's where they cross. This means that Andrew will catch up after 8 seconds. They will be 8 meters from the starting line. And there we are. We just did that. Now he's trickier if he got a 20-second head start, but he gets a 20-meter head start. Okay, and that's the whole assignment. Do it. Have a good day. Bye-bye.